Don't complicate things. So here, okay, let me try to make you be able to see that. Okay. Hey, can you see? Huh? At the back, can you see? Do you have the question?
Yes.
Are you sure you have got it? Oh, okay. Then that's fine. Oh, it's the one that I sent you on the group. Okay, that's a good thing. That's a good thing. Then I don't have to stress about it. So go to the group and locate the question. All right. So the question says, I think I've got it here too. Let me check. Don't worry, it won't take us long to do. All right. The depth D of water in a kettle t minutes after it starts to boil is given by dt equal to 86 minus 18 T minus a quarter T cubed. Okay? So where D is measured in milliliters, then 8.1 says, what is the depth of the water in the kettle just before it starts to boil? Okay? So we need to know the depth at T equal to what? 0. Okay? At T equal to 0. So 8.1, you have dt equal to 86 minus 1 over 8t minus a quarter t cubed. So you want d0, okay, before it starts boiling. So if you substitute, you get 86 minus, it's just 1 mole, so I just write 86. 86 milliliters. Okay? Okay, you just substitute t equal to 0. So you get, it's 1 mark, so we'll just write the answer again. Then 8.2, as the water boils, the level in the kettle drops. Find the rate at which the water level is decreasing when t is equal to 2 minutes. Right? Now, I want you to be aware that the concept of an increasing or decreasing function is required under rates of change. Okay? Remember, if the gradient is negative, then the function is decreasing. If the gradient is positive, then the function is increasing. So for you to be able to determine whether a function is increasing or decreasing, you need to determine the first derivative. So we're going to find the first derivative, then we substitute into that equation of the first derivative, t equal to 2. And then you get your answer. Okay, so let's move on to the next page. So 8.2, we have dt equal to, do you see that the given equation is a cubic function? It's a cubic function with a, it starts with a what? A maximum turning point, a maximum or minimum. It starts with a minimum, it goes like this, okay? So when you're answering these questions, also relate them to a cubic graph, a quadratic graph. Okay, so g prime of t will be equal to minus 1 over 8, and that one will be minus 3 over 4 t squared. Okay, remember 86 is a constant. The derivative of a constant is 0. Okay, and minus 1 over 8t, the derivative of a constant or a coefficient by a variable is equal to the coefficient. Right, then all we have to do now is substitute 2 into that. It's so easy. Okay, you get minus 1 over 8. That will give me 4, so I'll end up having 12 over 4. And then if you simplify this, you get minus 1 over 8 minus 3. And that will give you minus 3 and 1 over 8. Please, this is the rate of decrease. Okay, because the water is boiling now. Because it's minus, it means there is a decrease which is taking place. The water in the petrol is, the level or the depth is going down at that rate. So this will be milliliters per minute. Because you guys you are doing physics, you should be able to write the units too. Okay. Then the last one says, how many minutes after the kettle starts boiling will the water level be dropping at a rate of 12, I think that's 12 in 1 over 8 milliliters per minute. How many minutes after the kettle starts boiling? Okay? How many minutes after the kettle starts boiling will the water level be dropping at a rate of that? Okay? So, we have, remember here, we have our first derivative. Okay? Our first derivative is our rate. Our first derivative is our rate. So we are going to equate the first derivative to be equal to, here it says it's negative, we'll be dropping at a rate of 12.5 milliliters per minute. Okay, now I want you to be aware of this before I carry on. That this minus, it's an indicator that there is a drop which is taking place. So you can write this as 3 and 1 over 8 milliliters per minute. That's the rate of what? Of decrease. Okay. Then let's move on to the next one. So our first derivative is that one there, minus 1 over 8 minus that. I need someone to tell me that. So d prime, that's 8.3. d prime of t is equal to minus 1 over 8 minus 3 over 4 t squared. Okay? So when you substitute here, are you supposed to substitute a negative value or a positive value? Why positive? Why positive? Yes? Yeah, but you see, the rate, this is the rate of what? Of decrease. It's a negative value. Was here talking about the level dropping, which means we're talking about a decrease. So my question is, where is d prime of t there? Are we going to put a positive 12 and 1 over 8, or we're going to put a negative 12 and 1 over 8? We have to put a negative. Okay? Right, we'll carry on later. Earlier in the morning was for d prime of t for question 8.3, are we supposed to put a value for the rate which is negative or which is positive? That was the question. Okay, remember the gradient of a quadratic function can be positive or what? Negative. Okay, for this question, because the rate is negative, it means that we have to substitute d prime of t as a negative value, which is minus 12 and 1 over 8. That won't stop us from getting a value of t which is positive. Okay, we are dealing with a decreasing function. Because of that, we can substitute it as a negative. Okay, all right. So then we can put here 12. We can put We can put 12 and 1 over 8, but it must be negative. This negative here, it won't affect the final answer in terms of its negativity. So we get 1 over 8 there minus 3 over 4 t squared. Right? If I take it, I'll get minus 12 equal to minus 3 over 4 t squared. And that will give you minus 48 equal to minus 3t squared. So t squared is going to be 16, and your t will be plus or minus 4. Okay? Now, because time cannot be negative, it's a scalar quantity, then it means that we can say therefore t will be equal to 4 minutes. Okay, then you are done. Remember, that's a quadratic function. Okay, that's your quadratic function. It's like your equations of motion. You've got a straight line, you've got a quadratic function. Now, it's very important for you to connect that in order for you to be able to understand what's going on. Okay? So whenever you are answering questions on rates of change, connect your knowledge of increasing and decreasing functions together with the graphs of a cubic function or a quadratic function. Okay, there's a relationship. Okay, any question? Yes?
Sir, I did a question on this, and for a similar question, when they ask for time, in the memo they use the second derivative instead of the first derivative, and the third answer, and I'm confused as to why they did that.
You have to understand that it depends on the context of the question. Okay, the context is very important. Right? For this question here, the question is asking us after how long, okay, will the rate be 12 and 1 over 8 milliliters per minute? Okay, we need to know at what time is that rate going to be. So it's asking for the time.
But so the question I did, it was also asking for the time and the rate, but the memo of that question used the second derivative.
Right? Do you mind if you can maybe post that to the group?
Okay, I'll try to find it.
Okay, find the question and then you can post to the group. Anyway, we'll stop here. Any other question?
No, I came across these notes, and I just want to clarify if this is right or wrong, because I think it might help Tim. It said that when you use the second derivative, you actually find an acceleration. So could that not involve that?
Okay, but now when you start involving acceleration, it means you are dealing with calculus of motion. So I'm not sure, Tim. Hey, did your question involve calculus of motion?
It was talking about a rate in which you want to resolve or something like that.
Yeah, I think it's better maybe you show me the question. Okay. All right. Let's move on. I just need to. Okay. You can always catch up later. Okay. So you have your ST there, which represents any of those three at any time t. Then the first derivative, okay, of a displacement function, a distance function, or a function involving height is called the velocity. Remember, velocity is speed in a specific direction. Okay, speed and velocity are related. Just that speed does not involve direction, velocity does involve direction. So the first derivative of a displacement function, distance function, is actually the velocity if the direction is involved, or it can be the speed if the direction is not involved. Then the second derivative, okay? The second derivative is actually your acceleration. Okay, the second derivative is your acceleration. Now, you also need to be aware that acceleration is a rate itself. Acceleration is a rate. Okay, so if I connect what we have there, right, s prime of t, okay, s prime of t, it means ds over dt, and that's the velocity. Okay, right? If you use other function notation, s prime of t is equal to ds over dt, and that's the velocity. Furthermore, the second derivative, okay, because acceleration is the rate of change of velocity, so this is the same as dv over dt. We can write that using ds, and that can be written as d. Okay, my board is not calibrated properly because of issues that are beyond my control. So that's ds over dt of ds over dt. Now this generally is written as d squared s, okay, over dt squared. That's your acceleration, okay, which you can put here as your acceleration. Okay, so that's now it's supposed to be, that's d squared s, that's dt, so this will be d squared t squared. Okay, let me change this equation. This is not right. Now the velocity of ds over dt, that's d squared s, that will be d squared t squared. What am I writing? dv over dt, that's equal to d over dt, that's v ds over dt. And this we can write as d squared s divided by d squared t squared. That's what it is, so it's correct. Okay. And so I'm just using another notation for the derivative. So that will be equal to d squared t squared. Because this velocity here is equal to ds over dt. So we are trying to find the derivative of velocity. Okay, so that's ds over dt. We substitute here. The d and the d give us d squared s. D and d will give us d squared, and then you end up getting t and t will give you that. Okay. All right. Don't stress about this, but basically your second derivative is your acceleration. Okay. All right. I have a question. Can I move on? I have a question here. This one here. Right. Let's just do that. So I want you to write. Example, then copy that question there. Can you see it? All right, let me do that quickly. Remember, I told that we are not under pressure. You don't have to feel any pressure. Aware of the following. We are dealing with the distance of a meteor from the Earth. Okay, so as the meteor approaches the Earth, the distance between the Earth and the meteor decreases. Okay, at the point of contact, ST becomes 0. Okay, at the moment when the two come into contact with each other. Okay, when the meteor impacts on the Earth, then ST becomes 0. So the first question says determine the velocity at which the meteor approaches the Earth when first detected. Okay, when it's first detected, what is its velocity? Okay, so since this is a distance function, it means we need to find the first derivative. Okay, we find the first derivative, we equate it to, we simplify it, and then we get the what? The velocity. So, 11.1, right? Our function is st equal to 6,000 minus 600t minus 0.2t cubed plus 2 times 10 to the power of minus 3 t to the power of 5. Okay, so we need to determine the velocity there. So it will be dst, or you can just say st. Let me call it st prime. Okay, so st prime, that's the velocity. That's a constant, so that becomes minus 600 t, and that one, this is 10 to the power of minus 3 t to the power of 5. Okay, so that becomes minus 600 t, and okay, you get minus 0.6 t squared, right? And then
Minus 600
minus 600 what?
Oh,
Oh, yeah. Okay, there's no t, sorry. Sorry, thank you. No t there. All right, so this is minus 0.6 t squared. Is that what you got?
Yes.
And then here, we need to multiply. We need to multiply this 5 by 2 times 10 to the power of minus 3. What do you get?
10.
You get 10 to the power of minus 3, right? T to the power of 4. Okay? Now, when it is first detected, what is the time at that point? It will be what? 0. Okay? Now, it's very important for you to understand that here, the question is asking for the specific value. So, when it is first detected, that's t equal to 0. So, st prime of 0, okay, all that will give us 0, this will give us 0. So, it will be minus 600 meters per second. Okay? To minus 600 meters per second. Remember, velocity is a scalar, so this is very much possible to have that negative. Did you get that?
Yes, sir.
All right, let's move on to the next question. The next question says, show that the meteor will collide with the Earth at t equal to 10 seconds. All right, so for 11.2, I don't know how you approached it, but in my case, I'll just substitute that t equal to 10 seconds into the equation. If I get my S10 as 0, then I can conclude that the two what collided at t equals 10 seconds. So I need the equation. Can someone just fix down? It's ST equal to 6,000 minus 600T
Cube
0.2T cubed.
plus 2 times 10 to the power minus 3 T5.
Yeah, like that. So we need to say S10 is equal to 6,000 minus 600 times 10 minus 0.2 times 10 cubed plus 2 times 10 to the power of minus 3 times 10 cubed. Right? If you simplify this, what do you get? If you simplify it, what do you get?
0.
You get what? 0. So you must get 0. Then 11.3. 11.3. Right, 11.3, we want the what? The acceleration. So the acceleration at t equal to 5 seconds. Right, so we need to find the second derivative. right? S prime, what is S prime of t? The first derivative?
Minus 600.
Minus 600 t.
No, there's no t.
There's no t, okay. Yes?
Minus 0.6 t squared.
0.6 t squared.
And plus 0.01 t to the power of 4.
Yes, it's fine. It's fine. Yeah, it's fine.
I put it
It's
in the
10 times 10 to the negative 3 is 10 to
Yeah.
T4, so
Yes.
T4.
Yes.
Okay. So here, we just need to find the derivative of that. That's S double prime of t. That would be minus 1,2 t. Okay. Then 4 times that will give me 40. So that will be plus 40 times 10 to the power of minus 3 t cubed. Okay. Then you substitute the value of the time. So you get minus 1,2 times 5 plus 40 times 10 to the power of minus 3 times 5 cubed. What answer do you get? So you get negative 1. So that would be negative 1, like that. Okay, because okay, we are in maths, though we don't write like that. But generally, if you decide, you can write as 1 meters per second squared. Okay. In maths, they won't penalize you for the units, though, because not everyone does physics, so some people don't know what that meters per second squared means. Okay. All right. So that's it there. That's it.